Okay, hello everybody. We are going to continue our lectures on arches. I gave you a lecture on funicular arches and another one on parabolic arches, three-hinged parabolic arches, and this one on three-hinged circular arches. As long as this arch is not parabolic, is not a funicular arch, then this means that if we are taking a section anywhere in the arch, we will have the three internal forces. So what difference will it make between circular arches and parabolic arches? Only the geometry, how we are going to handle the geometry. In the parabolic arches, we got the equation of the curve, and then we got the rise of the arch at point B, for example, and the angle of inclination of the tangent with the horizontal at point D. But here in the circular arches, we are having different style. We are going to solve the problem with a different method. So immediately I'm going to give you a problem. Here it is required to determine the support reactions. We want to get the moment at point B, and we want to get at point D, I'm sorry. And we want to get the normal force at point D left, the shear force at point D left, the normal force at point D right, and the shear force at point D right. Okay? Now let us start our solution. Take care, as long as this is a circle, it means that this is the center of the circle, and the radius of the circle is always 12 meters, is the same. Okay? So I'm not going to give you except the radius and the angle subtended at the center. So if I would like to determine the geometry, here if you take this line, this distance here will be, this angle is right angle triangle. The hypotenuse is 12, the angle subtended at the center is 35, the adjacent is 12 cosine 35, and the opposite will be 12 sine 35. So this length is 12 cosine 35, and this distance here is 12 sine 35. So if you did that, you are going to get this distance here is 6.88, and this is 6.88. Okay? Now take care, I'm not giving you except the radius and the angle subtended. You should be able to get the span of the arch. Also, if you would like to get the height of this point, how can I get the height of this point? From the center, I am having this distance here is 12 meters, because this is the radius of the circle. And the distance below, we got it from the right angle triangle, because the hypotenuse is 12 and the angle here is 35. So the distance from this point to this point is 12 cosine 35. So if you'd like to get this height, it will be 12 meters minus 12 cosine 35. So if you did that, this will be 2.17. Now this is enough to be able to get the support reactions. So let me start here. Solution. Now we are having vertical reaction AY, and if this is point E, this is EY, and we are having horizontal reaction H, and horizontal reaction H. Okay? Now, what are we going to do? We can take moments about point E in order to get the reaction AY, because there I will have all of the reactions meeting at this point. Then I should be able to get the reaction AY. So I will say sigma, the moment about point E is equal to 0. This is the positive direction. Then we are having 6.88 plus 6.88 will be 13.76 AY minus the distance between the 5 and point E will be 8.88 multiplied by 5 minus the distance here between this load and point E will be 6.88 minus 4, which is 2.88 multiplied by 5. And then the magnitude of the distributed load, this is 6.88, then, and we are having here 2 meters, this length will be 8.88. So this is minus 2 multiplied by 8.88 square over 2 is equal to 0. From there, we get the value of AY, and this will be equal to 10 ton. Then we have sigma Fy is equal to 0. This is the positive direction. Then I am having AY plus EY minus 2 by 5 minus the resultant of the distributed load, which is 2 multiplied by 8.88 is equal to 0. From there, we get the value of EY, and this will be equal to 17.86. Okay? So we can write here this will be 10 tons, and this will be 17.86 tons. Now I want to get the horizontal reaction. We can either, of course, we are having an intermediate hinge. This is the one that is making the arch statically determinate. So I can take moments about this point either from the left-hand side or from the right-hand side. So let us do that. So we will take sigma, the moment about point C from the left-hand side is equal to 0. Let us assume that this is the positive direction, the same direction of rotation of the unknown force about point C, which will be equal to 2.17. Again, how did we get the 2.17? We know that the distance from point C to the center of the circle is 12 meters. And we know from this right angle triangle, the hypotenuse is 12. Therefore, the adjacent will be 12 cosine 35. So we said 12 minus 12 cosine 35, we get the height, which is, or the rise of the arch at point C, which is 2.17. So we have 2.17 h, and then minus the reaction at point A multiplied by 6.88, and then plus the concentrated load times its distance, which is 5 multiplied by 2, plus the portion of the load from point B to point C, which is 2 multiplied by 2 multiplied by its distance, which is 1, From there we get the horizontal reaction, and it will be equal to 25.25. This is 25.25 tons. Very good. Now he wants to get the moment at point D, okay? And he wants to get the normal force and the shear force left and right of point D. Now we have a very important requirement here. We want to get this distance, which is the height of point D, and also we want to get the angle theta, the angle between the tangent to the circle and the horizontal theta, this angle. Take care. When we solved the parabolic arches, we got first the equation of the arch. And we took the origin at this point, and we said the equation of the arch y is equal to kx square. But whenever we are having a circular arch, I would advise that we can solve by the geometry. We don't need any more mathematics. Take care. If you take one of the radius of the circle passing through point D, okay? What do we know about this triangle? This is a right angle triangle. Notice here, this is a right angle triangle where I know this width here is 4 meters. He gave me the 4 meters. The distance here is 4 meters. And the hypotenuse is 12. Okay? And this is right angle triangle. Therefore, I can get this distance. How can I get this distance from Pythagoras? I can say that the hypotenuse square minus the opposite square should be equal to the adjacent square. From there I can get this distance from the origin up till this point. I know from this triangle that the height from this point to this point is 12 cosine 35 from this triangle, right? From this triangle we are having the hypotenuse is 12 and the adjacent is 35. At this distance, we got this before. This distance is 12 cosine 35 degree. Okay? Therefore, we can take the height at point D should be equal to this height of the right angle triangle minus 12 cosine 35. Therefore, HD will be square root of 12 square minus 4 square minus 12 cosine 35. If you did this, you will get the value of 1.483. Okay, what else? How can I get the angle theta? Take care. This is the horizontal and this is the tangent to the arch. So this angle should be equal to this angle theta as well. Okay? Take care. What is the relationship between the tangent to the circle and the radius? The radius is perpendicular to the tangent. Therefore, the angle theta plus this angle must be equal to 90. Why? Because the radius of the circle is perpendicular to the tangent of the circle. Why don't you look to this triangle then? In this triangle, this is a right angle triangle. This angle plus this angle must be equal to 90 because this angle here is 90. Since this angle plus this angle is equal to 90 and this angle plus theta is equal to 90, this angle must be equal to theta. Therefore, in order to get the angle of inclination of the tangent to the circle at any point with the horizontal, it should be equal to the angle subtended at the center between the vertical and the radius to this point. Okay? يبقى how can we get the angle theta? We know the 4 meters and we know the hypotenuse is 12. يبقى we can say that sine theta is equal to 4 over 12. From there we get theta. Sine theta is equal to 4 over 12. From there you can determine the magnitude of theta, and it will be 19.47 degree. Now, once I solved for the rise of the arch at point D, and I solved for the angle of inclination of the tangent to the arch at point D with the horizontal, then I can proceed exactly similar to the parabolic arches. Let us start. Now we have these two values. Let us write them down here. The height at point D is 1.483 meters. And angle theta D is 19.47 degrees. Okay. First, I will get the moment. I will cut a section just right of point D like this. Okay? يبقى this is my section. I'm having here reaction 17.86 and the reaction 25.25, and here we are having the distributed load of 2 tons per meter. This distance we are having, this is 4 meters and this is 6.88, there remains 2.88. And this height here will be 1.483. Let us assume the internal moments. This is the moment at point D. We know in the arches there should be compression. يبقى this is the normal force, and the normal force is directed towards the point because we are having here compression. Yes, we took the right hand side of the arch, but the cut section is on our left. يبقى the positive direction for the shear is like this. Since we took the section right of point D, يبقى the 5 tons is excluded from my section, and this is right of D. We can now solve for everything. يبقى we are going to say, let us take the moment about point D itself, sigma. The moment about point D is equal to 0. This is the positive direction. Don't forget to include the internal moment that I want to get MD. Okay? We are having the 25 is rotating in the same direction. And we are having the resultant of the distributed load, which is 2 plus 2.88 square over 2. And we are having the reaction is opposite, negative 17.86 multiplied by 2.88 is equal to 0. From there, we get the moment at point D. And if you did this, it will be 5.41 meter ton. طيب. If I want to get the normal force and the shear force at point D right, take care either that we work with sigma fx and sigma fy is equal to 0. Here you will have to get the component of theta, the component of n dr, and also the component of q dr. Okay? Or we can take the summation of forces instead of taking the forces in the vertical and horizontal direction to avoid solving two equations in two unknowns, we can sum the forces along the shear and along the normal force so that we can get one equation in one unknown. Let me remind you with what we were doing before in this matter. We used to draw here a curve like this. This is the tangent to the arch, and this is the perpendicular to the tangent of the arch. This is theta, and this is theta, this is theta, and this is theta. This is point D right. We are taking the section right of point D, so this means that the 5 tons is not included because we are taking the right hand side of the arch. Type, let us sum all the forces that we have in the vertical direction. We are having here in the vertical direction 17.86, and we are having the resultant of the distributed load is 2 by 2.88. So this means that this will be 17.86 minus 2 times 2.88. Therefore, I will have here upwards, I will have 12.1. In the horizontal direction, we don't have except the 25.25. Very good. Type, the normal force, this will be the normal force, N D right, and the shear, this will be Q D right. Okay, now I'm going to sum the forces in the x prime direction. So I'm going to say sigma fx prime is equal to 0, and this will be the positive direction. What is the benefit from doing that? Because when you are summing the forces in the x prime direction, we don't include the component of the shear because the shear is perpendicular to the normal force. So the only thing that will be included, the component of the 12.1 and the component of the 25.25. Take care. Here we are having, if you completed this, I will have, this is the horizontal component of the 25, and this will be the vertical component. Okay? Like that. Because if you want to move from this point to this point, either that you move along this line or you are moving in this direction and then in this direction. Okay? And also for the 12.1, we can resolve that into two components like this. We can resolve it in this direction and in this direction as well. Because instead of moving along this vertical line, we are going to move along this inclined line and then perpendicular to it like that. Okay? So let me write in the x prime direction, I will be summing the forces. I'm having NDR, and then the component of the 25.25 in this direction will be negative because it is opposite. 25.25 times cosine theta, and also the component of the 12.1 in this direction will be opposite to the positive x prime direction, and it will be 12.1 sine theta minus 12.1 sine theta d is equal to 0. From there, NDR will be equal to 24.47 tons. Now this number is positive because we assumed in the very beginning that the normal force is compression, which means that it is confirming that the internal force is compression. The internal force in the arches cannot be tension, it must be compression. It is positive because we assumed it from the very beginning is compression, and because it is directed towards the section. Okay. Now if I want to get the magnitude of the shear. So I'm going to sum the forces in the y prime direction, okay, along the shear. So in order to do that, I will have here sigma Fy prime is equal to 0. I will take this as the positive direction. Then I am having the shear at point D right. The component of the 12.1, I am having this as the angle theta. So it will be plus 12.1 cosine theta d. And the component of the 25.25, it is now downwards. It means that it is opposite to the positive direction. يبقى it is negative 25.25 sine theta d is equal to 0. From there, the shear at point D right, if we calculated this, it will be negative 2.9 tons. Okay? يبقى this will be the magnitude of the shear and the magnitude of the normal force right of point D. How about left of point D? Now, if you want to take a section left of point D, you are cutting a section like that. Okay? Now, it is easier for us. This is the location of the section. Either that you cut this way and you take the left-hand side, or you cut this way and still take the right-hand side. When I am taking a section left of point D, not necessarily I will take the left part of the arch. Still, I will take the right-hand side because it is easier for me. يبقى what difference will it make in this diagram? Let me erase that. The only difference is that we are going to have here included in our section the 5 tons. Okay? So this means that, let me draw this figure immediately, like this. This is the tangent to the arch, and this is the perpendicular to the tangent to the arch. This is theta. Leave one angle and the other theta, the other theta, and the other theta. Now we are taking a section here, like this. So we are including this part. Okay? What forces will be included? I will have the 17.86 upwards and the 5 tons downwards, and the portion of the load here, which is 2 times 2.88 downwards. يبقى the result will be 7.1 upwards. Okay? And we are having the horizontal reaction, which is 25.25. And still, when you are cutting a section, this is your arch. This is the 5, and this is the distributed load. This is the reaction, and this is the horizontal reaction, 25.25. Now, what will be the internal forces? I will have, again, the normal force. I am assuming it to be compression. So the normal force will be directed towards the section. Still, the cut section is on my left. يبقى the positive shear will be upward like that. And the bending moment, of course, is the same, either left or right, because the concentrated load does not cause any change in the moment. So this is point D left. Okay? يبقى therefore the direction of the normal force, this is N D left, and this is Q D left. The same style, we are going to resolve this force into 2 components like this, and we are going to resolve this force into two components like that. Okay, so this is the x prime direction and this is the y prime direction. If I want to determine the normal force left of D, the only difference when we took a section left of point D, the only difference is that we included the 5 tons, and that's why the vertical force here became 7.1 instead of 12.1 as before. So we are having sigma fx prime is equal to 0, and this is the positive direction. يبقى n d left minus 25.25 cosine theta d, and this force is also opposite to the positive direction. يبقى minus 7.1 sine theta d is equal to 0. From there, normal force at point D left will be 26.14. Again, the positive sign indicates that we predicted the correct direction and the normal force is directed towards the section, then it is compression. Also, sigma Fy prime is equal to 0. We are summing the forces in this direction. We are having the shear at point D left plus the component of the 7.1. It will be cosine. This is plus 7.1 cosine theta D. And this component here of the 25.5 is against or is opposite to the positive direction. Then it is negative 25.25 sine theta d is equal to 0. From there, the shear at point D left will be equal to 1.82. What can we learn from this problem? That whenever we are having a concentrated load like this point, or a concentrated load like at point B or at point D, there will be an abrupt change in the shear and in the normal force. Like what happened here, the magnitude of the shear left and right of point D is different because of the existence of this normal force or of this concentrated force. But for the bending moment, there is no difference, of course, because the presence of the force will not change the magnitude of the bending moment. Now, this is an example of a typical three-hinged circular arches that you can have. I can also give you another problem as a matter of practice. Maybe that will require more calculations. Let us see that together. So let's have another example. It is required to determine support reactions and determine the moment at point B, the normal force at point B right, and the shear force at point B right. Now, this arch looks like this. For the first time, you will notice that the arch might not have the two supports at the same level. It says here that this is a circular arch and the radius is 10 meters. The angle subtended here is 20 degree, but the angle subtended here is 30 degree. This is a little bit a lengthy problem in calculating the support reactions. We are having a distributed load here. This value is 10 ton. And this is 2 ton per meter. This is point A, point B, C, and D. And this value here is 2 meters. How are we going to solve this problem? Take care. Now, from this right angle triangle, we can get this distance here. This distance will be 10 sine 20. If you did that, this will be 3.42. And from this right angle triangle, from the other right angle triangle, the hypotenuse is 10 meters because this is a circle. The angle subtended at the center is 30. This distance will be 10 sine 30, which is 5 meters. This means that the remaining distance here will be 3 meters. We also need to get the height. How can we get this distance here? Again, the distance from point C to the center of the circle O is 10 meters. And from this right angle triangle, we know that the hypotenuse is 10 and the angle subtended here is 20. This distance is 10 cosine 20. 10 minus 10 cosine 20 will give me the height of point C here, and it will be 0.6 meters. Type, if you want to get this height, again, I know that this distance is 10, and I know from this right angle triangle that this is 10 cosine 30. The difference will be 10 minus 10 cosine 30. It will be 1.34. This means that we are having a difference in level between this point and this point. This distance is 0.6 and this is 1.34. So the difference between them will be 0.74. Now we have the support reactions. This is AY and this is H. As long as we don't have any horizontal forces applied on the arch, the horizontal reaction here and there should be the same. This is H as well. And here we are having the vertical reaction dy. Now we want to determine the support reactions. Unfortunately, we cannot obtain this, we cannot get one reaction at a time. We have to solve two equations and two unknowns. Why? Because if you took moments about point D, you will have H and AY included. Then you are having one equation and two unknowns. You will have to select moments about point C as well, because this is an intermediate hinge. Without this condition, I couldn't have solved the problem. We can take the left part, then we are getting another equation in the same two unknowns. Then we can solve two equations, two unknowns simultaneously to get the support reactions, and we'll proceed identical to what we solved before. So let us have solution. I will take first moments about point D. Sigma MD is equal to 0. to get the first equation between H and AY. So I will have 8.42 AY and then minus, because it is rotating opposite, 0.74 H. We need to include the distributed load. This is minus 2 multiplied by 5.42 square over 2 and minus the force 10 multiplied by its distance, which is 2 plus 3.42, which is 5.42. This is the first equation. The second equation, I will take summation of moments about point C from the left hand side. I want to get another equation in the two unknowns that I'm searching for, AY and H. Okay? So when you take moments there, I will have, this is the positive direction, then I will have 5 EY minus 1.34 H, and then I will have to include the 10 tons times its distance, minus 10 by 2, and I will include the portion of the load between point B and C, which is minus 2 by 2 square over 2 is equal to 0. So this is the second equation. We solve for the two unknowns, AY and H, by solving these two equations simultaneously. Therefore, we get the value of AY, and it will be 12.45, and the value of H will be 28.55. And then from sigma Fy is equal to 0, we take this the positive direction. We are having AY plus dy minus 10 minus 2 by 5.43 is equal to 0. From there we get the value of dy, and it will be 8.41. Therefore we got the support reactions AY and H and dy. Now we finished this item. We want to get the moment and the normal force right of D and the shear force right of point B. Since we are talking right, then we are cutting a section here, right of B. Not necessarily because you are cutting the section right of B that you will take the right portion of the arch. Still the left portion is easier. Therefore we can cut right of B and still we take the left hand side. So we are going to cut a section. He told us right of point B, so we are talking here B right. And this is our section. Because we are taking the section right of B, we are including the 10 ton, and we are having this reaction AY, it was obtained 12.45, and we are having the horizontal reaction 28.55, and we need to get this distance. We got it already to be 3 meters, and we need to get the height of the arch at point B, and of course this is the tangent. This is the tangent to the arch. Then we are having, this is the direction of the normal force in B right, and the angle subtended here is theta B. Now we took the left hand side of the arch, but the cut section is on our right hand side. Therefore this is the direction of the shear at point B right. Okay, and we are having the bending moment. We are always assuming the bending moment, the tail of the arrow is under the datum to assume that it is positive. Okay, now we need to get the height and we need to get theta B. As before, we are going to look to this right angle triangle. Okay, this right angle triangle, we know from this triangle this distance is 2 meters, and we know the hypotenuse is 10 because this is a circle. Therefore we can get the distance from this point to the center of the circle, and we know that this height here is 10 cosine 30. Therefore we can get this distance, which is HB. Okay, therefore HB will be, this distance is root 10 square minus 2 square minus, from this right angle triangle we are having the hypotenuse is 10 and the angle subtended here is 30. This distance should be 10 cosine 30. So if you did that, we should be able to get the value of HB, and it is 1.137, 1.14 meters. Type. If you want to get the angle between the tangent and the horizontal, which is theta, it is the same as the angle theta. It is the same as the angle theta subtended at the center. And we have from this triangle, this right angle triangle, the opposite is 2 meters and the hypotenuse is 10. Therefore sine theta B is 2 over 10. From there, theta B is 11.55 degree or 0.54 degree. I'm sorry. Okay. Now let us go back to the free body diagram of point B right. We can take moments, summation of moments about point B is equal to 0. Let us assume this is the positive direction. We need to include the internal force MB. What else should we include? We are having 12.45 rotating in the opposite direction minus 12.45 by 3. And the 2.88, the 28.55, this is rotating in the positive direction, multiplied by the height HB, which was 1.14, is equal to 0. From there, the value of MB, we can get this, and it will be 5 meter ton. Since the sign here is positive, it means that the assumption of the internal force or the internal moment in this direction is correct. Okay, how can we get the normal force and the shear? Again, we are having this angle is theta, and also this angle is theta. Okay, we can resolve in the x and y direction, but we will have 2 equations and 2 unknowns to solve, or we can use our nice diagram that we just learned in the arches. Let me draw this here for you. So we are having, this is the vertical direction and this is the horizontal direction. This is the tangent to the arch. Sorry. The tangent to the arch is in this direction now. This is the tangent to the arch, and this is the perpendicular to the tangent of the arch. This is theta. Leave one angle and the other angle will be theta. Like this. Okay? Okay, in the vertical direction, I'm having 12.45 and 10. يبقى the result will be 2.45. And in the horizontal direction, we are having 2.28.55. Type the normal force. The normal force will be in this direction 28 point, the normal force in this direction will be NBR, and the shear on my right hand side and downward, because we are assuming it positive, يبقى this is QB right. Very good. Now I want to resolve the forces that we have. The 28 will be resolved in this direction, cosine, and in this direction, sine. Because if I want to move from this point to this point, either I will move like that, or I will move along this line and this perpendicular line like this. And also, the 2.45, I will move in this direction and then in this direction like this. Okay? So let us say here we are going to take summation of forces. If this is the x prime direction, so I will take the summation of forces in the x prime direction is equal to 0, and this is the positive direction. Then I am having N be right. Opposite to it is the component of the 28.55, so minus 28.55 cosine theta b, and also opposite to it the component of the 2.45, and now it is sine يبقى from there normal force right of point B will be 28.46. What is the meaning of the positive sign here? Because we know that in the arches the normal force is always compression, we assumed the force towards the section because it is compression, and we got the answer positive, which means that our assumption was correct. So the other component, the shear, sigma Fy prime is equal to 0. I will take this the positive direction. So this is the direction of the y prime. I will have Q be right, and then the component of the 28 is with the positive direction, so this is plus 28.55 sine theta b, and the component of the 2.45 is in the negative direction, يبقى this is minus 2.45 cosine theta b is equal to 0. Always whenever you are having one of the forces multiplied by the sine, the other one should be multiplied by cosine. But you have to watch the whether it is positive or negative. Okay, يبقى from there, if you did this, you will get QB right, and it will be negative 3.311 ton. What is the meaning of the negative sign? It means that it is not a positive shear, because we assumed the shear to be in the positive sense. Once I got the answer negative, it means that it is upward, يبقى it is on my right hand side and upward, يبقى therefore this is a negative shear. Now we took together 3 lectures in arches, funicular arches, parabolic arches, and 3 hinged parabolic arches and 3 hinged circular arches. Whenever you are getting a question, it could be one of these 3 arches, and you can see here the style of solution is the same, and we are directly applying the basic equilibrium equation in all of them. Okay. Now you should be able to solve the assignment on the arches and submit it on Thursday as we explained together. Okay. Thank you.